How could jealousy lead to an invention? And why would someone be jealous of a frog? Well, I'll tell you, and along the way, I'll talk about academic dishonesty, reanimating corpses, scientific rivalries, tingly metals, Napoleonic politics, and how we know that water is made of H2O. Ready? Let's go.
Electricity, 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 electricity.
In 1791, an Italian anatomy professor named Luigi Galvani accidentally discovered that a dead frog leg could jump if it was touched with a probe that was electrified with a static electricity machine. He then found that the leg could also move if it was touched with two different metals without any static or atmospheric electricity in sight. In other words, the two metals with the frog somehow created electricity. Galvani correctly determined that electricity was connected to life itself. Not unexpectedly, Galvani's paper took the world by storm. One person who was very interested in this paper was Italy's greatest electrical scientist, Alessandro Volta. Volta was a loud, boisterous man, a world traveler who spoke many languages, and was known by a contemporary as, quote, a genius who swore and cackled over his experiments, guzzled and disputed over his dinner, electrified the ladies, and understood more of electricity than anyone else in Europe. Volta first came to fame by, basically, stealing another person's invention, an object that Volta called the electrophorus. In the following years, Volta made several discoveries that are not attributed to other people, like discovering methane, but most of his fame came from the electrophorus and from his oversized persona. Volta began to repeat Galvani's work and found the results unbelievable and miraculous. He then got a live frog to jump with two different metals attached to each frog back. Volta decided that Galvani wasn't reanimating the frog, as even a live frog would move if it was in contact with dissimilar metals. He decided that the electricity came from the different metals, and the frog was merely responding to the electricity produced by the metals, just as it had jumped from the electricity from machines and from lightning bolts. Soon it became a big debate. Was a frog jumping because it had once been alive, or was a frog jumping because the two different metals created electricity? Quickly, the scientists of Italy and Europe began to battle between the Voltists and the Galvanists. By the way, both sides were partially correct and partially incorrect. Galvani was correct in that all living systems use and produce electricity to make their muscles move and their nerves transmit signals, which is why if you artificially add electricity, even a dead animal will react. Volta was correct in that two metals were creating electricity, which has nothing to do with the frog previously being alive. The big thing the Volta missed was the acid in the frog's leg that reacted differently to the different metals. In other words, he didn't realize that this was a chemical reaction and thus needed a chemical, an acid or a base, to work. Galvani was not really a good debater on the Galvanist side, as he had basically retired from public talks after the death of his wife, and as far as I can tell, was not a very competitive person anyway. Also, he lost his position due to his objection to Napoleon taking over Italy. Therefore, he left the argument to his nephew, Aldini. Aldini, despite being a professor of physics, was much more of an entertainer than a scientist. For example, he liked to do public demonstrations, twitching the eyes or mouth of a cow head, and even a human head of a decapitated criminal. This, for obvious reasons, gained the public's attention. He even went to London and inspired a young woman named Mary Shelley, who wrote a story in 1818 called Frankenstein. However, these dramatic displays did not help much in academia. The next year, Volta won a prestigious British award for explaining Galvani's experiment. However, Volta was unhappy. He didn't want awards for explaining other people's work. He wanted an award just for himself. Volta needed a decisive experiment, something that would prove that electricity came from the metals and not the frog. However, the only sensitive electroscope he had was a frog's leg, so he was a bit of a quandary. To prove his thesis, he needed a more powerful system with only inorganic materials. The first thing Volta did was to determine which metals worked best on the poor frog. and he found that silver and zinc seemed to have the greatest effect. If he put a piece of silver and zinc in his mouth, he would feel a slight tingle. But if he connected the silver and zinc to wires and put the wires on his tongue, he felt nothing. Volta started to wonder if the metal had to be wet. Therefore, he put the metals in a cup of water. Suddenly, there was enough voltage to be noticeable on his tongue. He then added 2 cups of water and got a stronger tingle. He called this a chain of cups. He then turned the experiment on its side. He put wet, thin cardboard between a pair of silver and zinc discs and stacked them together in a pile. In this way, he got a relatively strong tingle. Moreover, you could get more tingling by just adding more discs and by using salt water instead of plain water. Here was the non-organic object that would create continual electricity with no rubbing required. In fact, Volta had just invented the battery. He published his work in 1800 to tremendous acclaim. Of course, Volta did not actually call his device a battery. In fact, a battery was a term already in use for a set of Leyden jars, the most powerful electric device available at the time. Now, Leyden jars stored and gave electricity in a jolt, and the battery gave a continuous flow of electricity, so they are very different. However, Volta was trying to pump up his accomplishment. He often referred to his discovery as resembling an electric battery, so you can see how the name got co-opted. Volta's victory was complete. He demonstrated his new device to Napoleon, who he had no objection to, in 1801, who made him a count in 1810. The potential of batteries measured in volts, named after him, and often referred to as voltage in his honor. He won many awards and retired a wealthy man, never to do anything else worthy of publishing again, until his death 27 years later. Interestingly, in his famous paper of 1800, he still found time to insult his old rival Galvani, who had died 2 years previously, by writing that his research was motivated because, quote, I found myself obliged to combat the pretended animal electricity of Galvani. How did Volta's pile of metal and salt water compare to a modern battery? Well, to answer that question, I need to talk about 3 things. 1, voltage. 2, maximum current. Voltage is like the power in a water pump that adds water pressure in your pipes. Is there even when no water is flowing. Most disposable batteries have 1.5 volts of electromotive force. Just 4 pieces of silver and zinc with salt water will produce that much voltage, and a typical pile that Volta used would produce as much as 20 volts. You can actually make your own pile with pennies and tinfoil and paper soaked in vinegar. Now, the copper in tinfoil is weaker than Volta's silver and zinc, but can still easily make a battery with 3 to 5 volts of potential. However, there's also maximum current. That is like the amount of water flow you can get from the pipes. A typical AA battery usually can make a maximum of 200 milliamps of current. For a voltaic pile, the most it could produce was around 3 milliamps of current. This is not very much, but enough to power a remote control. So what did people do with Volta's battery that produced so little current and lasted only an hour? Well, they could make their tongue tingle, and they could animate dead animals and people. But the most useful thing they did with the batteries in the early 1800s had to do with chemistry. See, in the very same week that Volta published his paper on how to build a battery, a pair of English friends accidentally put the ends of the battery into a container of water. Soon the ends started to make bubbles. One probe would make bubbles of hydrogen, and one would make bubbles of oxygen. Plus, you had about twice as much hydrogen as oxygen. They'd proven the water was made of H2O. This electrochemical experiment inspired a young chemist named Humphrey Davy to make the world's strongest battery, and from 1807 to 1808, he managed to electrically isolate 8 brand new elements and increase the total number of known elements by 20%. Humphrey Davy's story is also a tale of how good looks, dramatic demonstrations, and prolific drug use made him a scientific rock star. And that wild story is next time on The Secret History of Electricity.
Electricity, 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 electricity.